Okay, so in this video, I'm going to talk about applying the Newton's third law onto a tension force. So tension force is along on the rope, right? There's no tension force. Tension force is zero. Tension force happens when you pull it, and then when the rope is tensed, it's going to be along the rope. So more tensed, less tensed, and you can measure the tension force. If you put this, let's see, scale, something like this, yeah. And I pull it here, around here, see, tension force. I guess more this way, tension force. I don't know if you can see it. More tension force. Maybe here. More tension force. More tension force. So it's very tensed right now. Tensed. More tensed. More tense. Very tensed. Very tensed. Not too much tensed. So you can use this scale to measure the tension force. And let's see this on note. Here. Okay. Tension. Tension force. Let's say I have an object that's hanging, and this object weighs 10 Newton. Here, the tension force here. How much does this tension force read? What do you think the force at that location? How about here? They should be both 10 Newton. In fact, can we have a tension force along the rope that's different? Can you have a tension force like over here is 10 Newton, but over here is 5 Newton? Different tension force? If you don't count the mass of the rope, then tension force should be same everywhere. Newton's third law of motion, right? At this part, you have a force pushing this way, then it's going to be a force that's pushing in the opposite direction, equal in magnitude everywhere. So 10 Newton here on the one side, that means that 10 Newton on the other side. Correct? It should be, there's going to be another 10 Newton here. 10 Newton pulling the ceiling down and up. So let's see. What if I have an object, this 10 Newton object? Right? I put a scale. What does this read? This scale will read 10 Newton. Now I'm going to flip the scale. So first, I put the scale like this. Maybe I'm going to put the scale like this now, right? So I'm going to put the scale this time. this way. How much does this one read? 10 Newton. Doesn't matter which way, right? It's reading. How about this? What if I put same weight, but in this kind of a configuration? Ten Newton, like this. What do you think that this scale would read? It's gonna be 10 Newton, right? Because it's 10 Newton here, 10 Newton here, 10 Newton there. It's gonna read 10 Newton. This one and this one, or this one, is almost the same thing. You have a 10 Newton that's pulling it down. So it's going to read 10 Newton. So now, this is going to be a question I'm going to ask in a class. So you should have your answer ready. What if I put the scale? But this time, 10 Newton down. Ten Newton down. What does the scale read? What do you think would be that? What do you think the scale would read? All right, so I'm going to ask you that in a class. You should have your answer ready. I mentioned that tension force is going to be the same everywhere, right? You cannot have any more than that. Let's say if you pull my hand and then somebody else is pulling my other hand, all around, I'm going to have the same tension force. 5 Newton, I should have a 5 Newton if I'm completely tense, right? So if it's what does it say? Yeah, this is 5 Newton. 5 Newton on this side, then it's going to be the 5 Newton on the other side, everywhere. If this is 10 Newton, then it's going to be 10 Newton on the other side. You can even feel it at the end, right? If I'm pull this hard, my other hands also hurt more. Oops, and come out. So the tension force is everywhere the same. How do you win the tug of war? How can you win the tug of war? Let's see. All right. Oh, I'm sorry. You got caught. Let me see. Here. See. Little more than 20 Newton. Like 20 Newton. 20 Newton. 20 Newton. So one side pull 20 Newton, the other side also reads 20 Newton. Because that along the rope, tension force has to be the same. So if that's the case, how do you win the tug of war? Can you ever pull harder than the other? Is it that daddy's not pulling as hard enough that he can pull harder than a 5-year-old daughter? What do you think? Maybe because they're not pulling hard enough. That's why they're not winning a tug of war, and then it's the same tension force. Yeah. So let me know. Question one, can you pull harder than the other? How to win the tug of war? Okay, so we're going to discuss this in a class, in a discussion. And yeah, otherwise I'll see you in the class.